Okay, we're going to look at dehydration synthesis in an animation. And here we have a glucose and a fructose, which are both monosaccharides. They're going to come together and the water is going to pull off. We'll watch this a couple of times through here and form sucrose. So again, monosaccharide, monosaccharide forming a disaccharide by losing a water. You'll notice one red oxygen, two hydrogens, water droplet falls off. So the end of any type of a reaction, you're going to see a water at the end. So again, one more time, monosaccharide, monosaccharide, making a disaccharide by pulling out of water, so there's a bonding location between a carbon and an oxygen. And there it goes. And that's that process. Now, to see this with structural formulas, we take a look at a disaccharide animation. Glucose and fructose. Can come together and they can form a disaccharide. Just going to refresh that. And here you have a glucose and a fructose, both formulas C6H12O6, and they can come together and form a new disaccharide. Now, I'm going to pause the video there and ask the question, what is the chemical formula of that new disaccharide? We lost the water. So you can't just double it. So it's not simply C12H24O12. It is C12H22O11 because it lost an H2O. So there was sucrose. Now we can have galactose and glucose forming lactose. And now we could have glucose and glucose forming maltose. And you can see the water drop off of each and the new bond forming between a carbon on the angle and an oxygen. In terms of diagrams of dehydration synthesis, it's important to take a look at your PowerPoint presentation. Dehydration synthesis, again, you'll notice glucose and glucose is maltose, which you just saw in the animation. Here we have an OH and an H, which is H2O pulling off, and that opens up a spot for the bond to happen. We've got a monosaccharide, and a disaccharide. Here we have glucose plus fructose, the water comes off and we form sucrose. Monosaccharide plus monosaccharide equals disaccharide. In a similar reaction, we can reverse it by doing a process called hydrolysis. Hydro means water. So through hydrolysis, we can add water and actually split up a larger molecule into two smaller ones. So here we have sucrose, which is a more complex sugar, C12H22O11. And I want to split it up, or my body wants to split it up, into glucose and fructose. And the way I'm going to do that is I'm going to use an enzyme called sucrase. Remember, enzymes end in ase, sugars end in ose, and I'm going to add water. And what's going to happen is the water is going to grab on, and the OH goes with the glucose, and the H goes with the fructose, forming an OH on that side. And there you have monosaccharide, monosaccharide. So it basically is sucrose plus water equals glucose plus fructose. I hope that was helpful in reviewing the ideas of dehydration synthesis. Dehydrate, pull the water out. Hydrolysis, hydrolysis, add water. Fire hydrant, hydrate, water, hydrolysis. Add a water and split it. Dehydration synthesis, pull water out and synthesize, bring together.